Alright, let's talk about Descartes' rule of signs. Basically, what happens is you can look at the equation and you're counting sign changes. To find out how many possible positive sign changes you have, you're going to look for sign changes throughout the equation. So notice here I go positive to positive, nothing changed. But when I go positive negative, I have one sign change, and negative positive gives me two sign changes. So what this tells me is I have either two positive solutions or you decrease by an even number. So I can have 2 or 0 positive solutions. Now to check for negative solutions, what I'm going to do is I'm going to plug in a negative x. And for x, so basically what's going to happen is when I do f of negative x, the only thing that's going to change signs are the odd exponents. So I get a negative 7 x to the third plus 3x squared plus 5x plus 9. Now I count sign changes here. I go negative to positive, there's 1. Positive to positive, still 1. Positive to positive, still 1. So for negative solutions, I have 1. And I can't go down to 0 because I have to account for pairs. The reason why I account for pairs is I'm looking for imaginary solutions. Now, this is good because I know at least I have one negative solution that works. So when I'm using the rational zero test, I'm going to be plugging in, doing synthetic division with a negative number first, because I know that there's guaranteed to be at least one negative. I don't want to do a positive one because I might have 2 or I might have none. So when I make a sign chart for what my possible solutions are, for positive, negative, and we also have imaginary possibilities. I could have 2 positives, I have to have 1 negative, and since my solution count is 3, this is an x to the third, I have no imaginaries. I have to have 1 negative, or I could have 0 positives, which means I could have 2 imaginary solutions. And that's what Descartes' rule of signs does.